change this one back to 0. And the point P is currently 2 units away from the origin, right? It's right here. And theta is 0. So, I'm going to increase it. And look at that. Look at what I was plotting over there. 2 cosine 4 theta. Okay, so this is sort of preliminary drawing, trying to understand, in an attempt to understand how R is controlled by theta. So let's theta goes from 0 to pi over 8. 0 to pi over 8, what happened? It does this.
0.
0 to pi over 8. Does that make sense? What happened? Because start with this direction, and then a short moment later it is in this direction with this radius, and next moment it is in this direction with this radius, and the radius you see is shrinking. Okay? Why? Because you see from here to here it's dropping down to 0 after pi over 8, and that gives you this branch here. Okay? But then if you look at that graph over there, the next pi over 8, you're going to see this drop into the negative territory. Is that right? And so what happened? At the end of the previous period, it goes like this, is almost tangent to this line. And then it hits the origin. It's going to overshoot. Okay, so now you're dealing with really this part of the angle. But your R is what? Negative. And therefore, your point appears in this region. Right? Even though the angle suggests this region, but the R is negative. So you'll see point entering that region. So let's see. So let me show you that next pi over 8 is going to be like this. See that? Right? Now, so over here, you see this one, this has to do with this part. Now R becomes the most negative possible. And that's this point. Okay, the direction is actually which direction? This direction, but R is negative. So the opposite direction. So then you keep going. At this moment, R is very negative, the most negative. And then now R becomes less negative. And therefore, it's get closer to the origin. And so for this part of a journey, from here to back to the origin, the theta is in this range, in this sector, but the R is negative, so you should look at the opposite sector here. That will be this region. That's exactly where the point is located. And so now it's swinging back to the origin, and as it does so, it's almost tangent to this line, right? So it's going to overshoot, and it's going to re-emerge on this side, and that will be the next sector. Okay, so if you keep going, it's going to be that sector, and that is right. That's the next sector. All right? So where the theta now is here, and the R is positive, so the point is indeed in that sector. And the thing just keep going again and again and again. Right, so right now you see the pattern. You know that next thing that it does is to go back to the origin, very tangent to this direction, overshoot, right, still very tangent to the opposite direction, and then keep going. And now it's very far away from the origin. Turn back to the next sector, which are actually negative, you know, and then continue to do this. Next low, overshoot. Next low, approaching origin, overshoots. Next low, approaching origin, now re-emerge. Very close to that line, re-emerge on the other side, very almost tangent to it. And now it turned around, finally return to where we started. Okay? So if you do this by hand, then you have to constantly look at that one. Okay? And that tells you how theta is being controlled, R is being controlled by theta. Sometimes positive, sometimes negative. If positive, it's in that sector of theta. If negative, it will be actually on the opposite sector. You know. So that always takes, it takes some coordination between this view and that view. Right? But with a little bit of practice, you know, shouldn't be that hard. But at first it will be overwhelming, of course. You know, but after there are several similar problems. You can tweak this number, this 4 here, and you'll get slightly different shape. But it's all the same idea. And I can change cosine to sine. It's still sine. All right, and that's the most complicated one. And I hope the calculation of the slope is okay. All right, you know, here's a problem. This is number, still within 10.3. There's a little bit calculus involved, and that is that if I have R equal to 2 sine theta, and then when at theta equal to pi 6, exactly at that point, find dy dx at theta equal to pi over 6. And this should be fairly straightforward, because what it takes is, you know, x is what? R cosine theta is something that you have to firmly keep in mind. And then likewise, y is equal to r sine theta. But since this polar equation has theta expressed in terms of, r expressed in terms of theta, so everything is being controlled by theta. So you simply use theta as a parameter. And so therefore, you look at dx d theta, calculate it. Well, by the way, perhaps you should write this first. R is being controlled by theta in this way, so 2 sine theta